Assalamu alaikum. Good afternoon. Today we'll start a new chapter, which is about air and water. First, how we can test the presence of the water or check the presence of the water. The chemical test for water is what we can do. We can use cobalt chloride. This is one compound. Originally, this cobalt chloride is blue in color. So cobalt chloride is blue in color and anhydrous copper sulfate is white in color. If you want to check the presence of the water, like a substance contain water or having water, what we can do, we can add these chemicals. If we add cobalt chloride to a container, we don't know whether the water is there. So we want to test or check the presence of the water. So what we can do, if we have a liquid which can be water, so to identify that whether it is water or no, we can test with a cobalt chloride and anhydrous cobalt chloride, which is originally blue in color. So it will change its color from blue to pink. And or we can add copper anhydrous copper sulfate. If we add anhydrous copper sulfate, it will change its color from white to, because originally it is white, but when water is present, it will become hydrated copper sulfate. So it will turn to blue. So you have to learn this test to check the chemical test to check the presence of the water. Is it clear? The test to check the presence of the water.
Sir, can you explain one more?
You have a container and you want to chemically test or check the presence of water. You don't know whether this container is filled with water. So what you can do, you can test with anhydrous cobalt chloride. What is the color of cobalt chloride? It's blue originally. So if you add this to a container which you think is having a water, so if there is a water, this compound will change its color from blue to pink. So this confirms the presence of the water. Or you can take copper sulfate and anhydrous copper sulfate, which is originally white in color, a white solid. But when you add to a container which is filled with water, it will change from white to blue. So both of these tests confirms the presence of water. The chemical test. So if you have a question, write a chemical test to show the presence of the water. So any one of them you can write. But you should learn both, and any one you can write if a question is there. Copy this part. Then a purification of the water. The process, how we purify the water. So first thing, we store the water in the dam and reservoirs, like the flowing water, the river is there. So we stop this flow and we store the water in the dams and reservoir. And this water is not a pure water, it contains dissolved impurities as well as insoluble impurities. So first what we do, this is a whole process, like a complete process, but for your O levels, you don't have to learn in detail this much detail. Only the specific points you should know for purification of the water. So for purification of the water, what we first do, like the water we store behind the dam, just to store the water. Then first thing is the screen, like it's filtering the large particle. So water is pumped in and a screen trapped any big particles such as twigs are there, parts of the, like some stems are also there. So the main function is to remove the large particle passing through the screen. Then the second process is coagulation or coagulant. What happened? We add a aluminum sulfate or iron sulfate is added, because what this water contains fine particles. So as this water contains fine particles, it is difficult to separate them, it's difficult to filter, because they're able to pass through the filter paper. So what we do, we use a coagulant here. Normally aluminum sulfate or iron 3 sulfate can be used. So when we add this aluminum sulfate or iron 3 sulfate, it will join these it will attract the fine particles. So when it will attract the fine particle, these fine particles turn into, join together. So these fine particles join together and it will turn into a large particle. And for this large, when they turn into large particle, we blow the air from the bottom. What is the advantage of or doing this process? As we blow the air from the bottom, these particles will move at the top. So as these particles move at the top, it can be skimmed off from the water. After that, we carry out another filtration, but this filtration is through, this is called a sand filtration. What is a sand filtration? Means we have different particles of sand, different size of sand particles. Large, like coarse sand is there, then fine sand is there, silt is there. So we pass this water through this sand filtration. What is the advantage? The water is passed through this bed of a fine sand, and this will trap, if any trace of fine particle are there, that will also trap. This water may have some like smell is there. To remove any smell, we pass over a charcoal, and after that chlorine is added. What is the purpose of the chlorine? It's to use to kill the bacteria. And then a fluoride compound is added to some plants, like chemical, this what, to help the tooth decay. Otherwise it may have soluble substances which can cause a tooth decay. So this fluoride will help to resist this tooth decay. And this water is pumped to the storage tank and then travel to the, like used by in home we are using it. Is it clear the process of purification of the water? So first a screening is done. Screening will remove the heavy particles. Then we add coagulant or coagulating agent such as iron 3 sulfate or aluminum sulfate, which make these small particles join together. So it will settle down, then aeration or air is blown so that it will make these particles float at the surface and skimmed off. Then we carry out another filtration, but this time filtration is through the sand, different types of different size of sand particles. Then a charcoal is just to remove any taste or the smell is there in water. Then chlorination is done. The purpose of the chlorination is to kill the bacteria or other microbes. And fluoride compounds are added to reduce the tooth decay. And then water is pumped into a storage reservoirs, and which is ready for pumping to home. So the part I want you to copy is step 1. Just mention the step, you don't have to draw 2, 3, So these are the steps which are involved for this purification of water or making this water drinkable for a domestic use. Any doubt in this? Copy this part as well. Okay, so this is about the purification of the water. Then some uses of the water. What are the uses for drinking, heating, plumbing, and for industrial water act as a solvent or as a coolant? The next one is a composition of air. So composition of air, you don't have to learn percentage of nitrogen, oxygen in inhaled and exhaled here. Only the composition, like example, for nitrogen about 79%, oxygen 21%, argon 0.9%, carbon dioxide 0.03, other gases other than 0.07, and water, water vapor, it's variable, like it does not have any fixed proportion. How we can separate these gases from each other? If you want to separate nitrogen, oxygen, argon, the gases are there. So which technique is used to separate the gases from each other? Which technique is used to separate? So we use fractional distillation to separate these gases from each other. But before carrying out a fraction distillation, we remove two things from this sample of air. Number one is the water, and number two is carbon dioxide. What is the reason why we remove carbon dioxide? Because carbon dioxide sublimate, means it convert directly from gas to solid. So that's why carbon dioxide is removed. And water, why we remove water from the mixture? Because it is variable, its percentage is not fixed. So it is variable, it changes. That's why we remove both of them. How we remove carbon dioxide from the water, from the sample of air? So to remove this carbon dioxide, we bubble through sodium hydroxide. To remove this chemically, passing the air through sodium hydroxide, because sodium hydroxide will react with carbon dioxide and it will form sodium hydrogen carbonate. So sodium hydroxide react with carbon dioxide. This will result in a formation of sodium hydrogen carbonate. So this sodium hydrogen carbonate will be aqueous. So the carbon dioxide is removed from the sample. And how we remove a water from the sample? We can use any drying agent. Can absorb water. And which drying agent we can use? We can use a silica gel, or we can use anhydrous cobalt chloride or copper sulfate as a drying agent that will absorb. So these two are removed, and then we have nitrogen, oxygen, argon, and other gases. Now, what we want to do, we want to liquefy them. We want to make them liquid because fraction distillation is done for liquid. So we liquefied them. So air is liquefied after removing this water and carbon dioxide by a compression and a cooling method below the boiling point of both oxygen and nitrogen. So most of the air becomes liquid, and the liquid air is allowed to warm. So when the liquid air will warm, like example, first we cool down this liquid air, and liquid air is pale blue in color, light blue in color because of oxygen. We liquefy the air around 200 degrees centigrade. Okay, so it is in a liquid state. The boiling point of nitrogen is minus 195, and boiling point of oxygen is minus 183. Boiling point means temperature at which the substance changes from liquid to gas. So when we allow it to warm, like we are not supplying heat energy, minus 200 is a very low temperature. So if we allow it to cool, to warm because it is cold, so first, which gas will liquefy first, nitrogen or oxygen? Sorry, which gas will vaporize first, convert into gas? Which element, nitrogen or oxygen, will vaporize or convert into gaseous state first? So nitrogen will, because when it will become warm, it means its temperature is minus 200, then it will become minus 199, then it will become minus 198, minus 197, minus 196, and so on. So when it reaches minus 195, what happens from the sample? Nitrogen will escape. So first nitrogen will escape, and once it reaches minus 183, then the oxygen will also escape. So this technique is used to extract nitrogen and oxygen from the air, and technique is known as fraction distillation. Is it clear? The fractional distillation of air. So I want you to copy this fraction distillation of air, add two parts after writing fraction distillation of air. The first step is passing air through sodium hydroxide, remove carbon dioxide, passing air through this, or passing over drying agent, which will remove water, and then these steps. For the car catalytical converter, what is the purpose of this car catalytical converter? Because what happened as we burn the fossil fuel like petrol, we are burning the petrol inside the car engine. So this combustion release harmful gases. Like example, petrol is octane. Octane means C8 and H18. So when we burn in the presence of oxygen, it gives carbon dioxide and water vapors. But if an incomplete combustion is there, it gives unburned carbon, or it also releases carbon monoxide. Unburned carbon or carbon monoxide are harmful because this can make a smog. Smog means the combination of smoke and fog. That's called smog. And carbon monoxide can cause suffocation. So it's not it's harmful. So this car catalytical and it also release oxides of nitrogen. So how oxides of nitrogen The fuel does not contain nitrogen, but how oxides of nitrogen? Because it is taking, the engine is taking air. So air contain nitrogen and oxygen. So as air contain nitrogen and oxygen, due to the high temperature or in the presence of the spark, the reaction between nitrogen and oxygen occur and it will form nitrogen monoxide. So this nitrogen monoxide, a brown gas is there that can also uh, make a photochemical smog, leads to smog. Here refers to like a combination of smoke and fog is called smog. As well as nitrogen is a non-metal oxide, so which is acidic oxide. This can cause acid rain. So what is the advantage of using this catalytical converter, a car catalytical converter? So this will reduce the emission of unburned hydrocarbon, carbon monoxide, and nitrogen. Like this is a car catalytical converter. Fine wires are there, platinum coating wires are there, or palladium, which we are using as a catalyst. So what it will do, it causes a reaction between, like the overall reaction, carbon monoxide and oxides of nitrogen in the presence of this catalyst. What it result? It will result in a formation of carbon dioxide and nitrogen. So carbon dioxide, it can cause a global warming, but it has less effect to the atmosphere as compared to carbon or human body as compared to carbon monoxide. And nitrogen is inert in nature, so does not cause any harm to the human. So it reduces the emission of carbon monoxide and oxides of nitrogen. And what happened to the unburned carbon? So oxidation, because there are two things. One is oxidation catalyst, another one is reduction catalyst. And then the overall equation is there.